we get into more and more contents of the antiderivative or the integration. And this is the first technique of integration. And you're going to use the most whenever that you are working on the problems involving antiderivative. Okay, we're going to look at the two types. The first one is called indefinite integral. Second one, definite integral. Indefinite integral is the integral that has no lower limit, upper limit indicated. And the answer or the result comes out as the antiderivative plus c. Okay, c indicate the constant of integration, or it represents the family of the antiderivative or all possible antiderivatives that their derivative is the same as the f of x or the integrand. For the definite integral, it has the form that has lower limit, upper limit indicated. The result comes out as the antiderivative evaluated at the lower limit and upper limit by using the upper limit first, subtracted by the antiderivative, replacing it with the lower limit. So this is from the FTC, or the fundamental theorem of calculus part 2. Okay, and the last part, we look at the geometry of substitution. That is the portion that you can see the graph of the original version comparing with the graph that represent the area of the new form, or when you substitute with another variable. The shape or the geometric shape gonna be different, but the area will be the same. So that's the whole point of the last part, or the geometry of substitution. Okay, for the indefinite integral, the first part as a substitution rule for indefinite integral. The u function, u is a function gx, where g prime is continuous on the interval, f continuous on the corresponding range of g. Looks like we have g and f. We treat u as a function of the g and has f involving in there. And on the interval, see the first part here is the function of the g, which is a function of the u, multiplied by the differential u, which is g prime x dx. That is the use of the chain rule. The whole point of this is to change from the complicated integral involving the x into the integral involving the u form, the function of the u, from the x into the u, from complicated integration into the less complicated integration. Okay. Now the whole process of using the substitution rule, or another way we call the change of variable. I'm gonna change the color here a little bit and make this bigger. I mean, not bigger, but fit in the screen. Just hang on for a second. Have to adjust every time. All right. So for the process of the substitution rule, you see, you are given the indefinite integral, which is in the form of the integral of the f of x with respect to x. And the function is the composition function. The f, you see f as the inner function, outer function composed to each other, or the composite function form at some point. And then you introduce the u to represent the inner function. The key term here, gx is the inner function. The u is the inner function part of the integrand. Okay, and then you're gonna see the rest of the integration will be in some form of the derivative of the inner function. It sounds complicated, but I'll walk you through the example. The first part, look at the expression, identify the inner function. Let u be the inner function. when you have u as an inner function, you find differential u. How do you find the differential u? You find the derivative multiplied by dx. Okay, and after that, you evaluate the new indefinite integral with respect to u. At this step, step 3, now you do with respect to the variable u. At the beginning part, you do with respect to the variable x. Now you transform from the x to the u version, and it should be less complicated. When you are done working on the antiderivative with respect to u, the last part, you're gonna get back to the x term by replacing u with the expression gx that you start at at the beginning. So it's like a cycle. So you start, let u be g of x, work on the antiderivative with respect to u. Whatever you get, you go back to substitute u with the gx term to get the result of the original integration. Okay, so let's work on the example. Hope you can see better picture of the process. Use the given substitution. The problem gives you the substitution to find the indefinite integral. Indefinite, recall, no lower, no upper limit, just a plain integral sign with the integrand. And then we can check the answer at the end. Okay, so with this one, as you see the substitution or the given expression here, u equals x squared plus 1. The reason that u equals x squared plus 1 is the expression that we have. I'm going to put a note here. So note the original integrand, which is 2x multiplied by the radical x squared plus 1. You see the product of the function, but the portion, the radical, the square root of x squared plus 1. The x squared plus 1 is the inner function. So this is the inner function. So that's why we let u be x squared plus 1. Okay. Now, since you see this as a composite function, let u be x squared plus 1. The next step, or step number 2, you're going to find the differential u. What is du? Recall when you find the derivative of the u prime, which is du by dx, right? Du by dx. The derivative of x squared plus 1 is 2x. So then the differential u is u prime times dx. That means du is 2x times dx. So this is step number 2. And after that, you're going to replace u and du, or in some form the u into the expression here, or the main part of the problem. Now the integral, the radical here, the u squared plus 1, the x squared plus 1 is replaced with the u. So I'm going to have the square root u, right? And then for the portion, 2x multiplied by dx. That's 2x multiplied by dx equals du. Now we have du multiplied to square root u. That means we have the integral, or the indefinite integral, u to the power 1/2 with respect to u. Now we are at step number 3. Find the antiderivative of u to the 1/2. Add the power by 1 to get 3 over 2. 3 over 2, use it as a denominator. If you divide by the fraction, it's the same as multiply by the reciprocal. Then we get this term divided by 3 over 2, which is the same as multiply by 2 over 3. Again, this is indefinite integral. You're going to add c at the end. The last step, you're going to replace u with the expression that you started with. For this problem, the u is given to be x squared plus 1. So you replace u with the x squared plus 1. So x squared plus 1 to the power 3 over 2, and then plus c. And this is the final result. Okay, I'm gonna put a note here one more time. As the first step, introduce the new variable, which is called the change of variable. That's step one. You see the inner function as the new variable u. And then step number two, you substitute u and vu into the integral form. And then next step, you're going to evaluate the new indefinite integral with respect to u, which is the result in step number 3 here, which is 2/3 times u to the power 3/2 plus c. And the last step, you replace the u with the x squared plus 1, and then you are done. Given you a sine x, okay, the problem already provided, so that's the first step already taken care of. Now, for our convenience, I just see sine to the third power here. That is the quantity of the sine x to the power 3. Just put the notes just in case you don't misuse the term. From the first step, we're gonna find the differential u. If you are not sure, just start with the du dx. Du dx, which is derivative. Du dx is the derivative of the sine x or cosine x. And then use the derivative notation here to find the differential u, which is the derivative multiplied by dx. Okay. Now we have u and differential u. We're going to substitute into the problem or the integral of the original form. From the sine x as the u term, so the first part here will be replaced with the u to the third power, okay, because sine x is u. And then the rest of the integrand, we have cosine x times dx, which is exactly the same as the du. So this part is replaced with du. At this point, we have the integral involving the u variable, which is much less complicated than the original form. Next, apply the power rule, u to the fourth over 4. Don't forget to add c because this is indefinite integral. And now the last step, u is sine x. Then replace u with the sine x quantity power 4 to finish up the problem. And you are done. We did not check the solution. We can check the solution real quick. Okay, what is the derivative of 1 over 4 sine x quantity power 4 plus c? The constant multiple 1 over 4 is doesn't change. I mean, it doesn't change. It stays as 1 over 4. The power 4, this time we're going to use chain rule because you have the quantity raised to the power. So it's 4 times that quantity power is reduced to be 3, and find the derivative of the sine, which is cosine x. So reduce. Now we get back to sine to the third power of the x multiplied by cosine x, which is the same as the integrand. So we are done. That's a checking process. But the first example, we did not verify the answer. So we can do that real quick on the note here. So the derivative, this is the checking process, checking solution process. d by dx of 2 over 3 of the quantity x squared plus 1 to the power 3 over 2 plus c. Constant multiple 2 over 3, the power 3 over 2, the quantity x squared plus 1 raised to the power that reduced by 1, which is 1/2, and multiplied by the derivative of the inner function, which is 2x. Derivative of c is 0, and now we can cancel or reduce the numbers to get 2x, which is in the back here, right in the front. The 1/2, that is the square root of the quantity x squared plus 1, which is the same as the integrand.